With its open platform concept, Doxis4 offers a variety of different interfaces. Solutions range from standardized interfaces to systems such as SAP, Salesforce, SharePoint, or Outlook Exchange, to generic interfaces to which almost any system can be connected in any form. These range from simple data exchange interfaces in the form of metadata or documents, all the way through to complex functional requirements. In this scenario, we are dealing with an incident on the UK national grid. In this situation, the remote support engineer is using a GIS system to assess the incident and create a case. We'll show you how Doxis4 can be integrated into said GIS system. The remote service engineer opens a map of the UK on which the national grid is mapped. All the grey lines represent power transmission lines in the national grid. The red place marker highlights an incident that requires our attention. If we click on it, we can see that this incident is related to a power surge on the grid at this location. To avoid the situation escalating, we need to examine the surrounding substations for problems. Let's start with the power line. If we click on one of the surrounding lines, WebCube opens a new window. All hourly reports pertaining to this power line are loaded and displayed. Thanks to the color-coded entries, we can immediately see that there are problems on this section of the grid. We'll click on the entry marked as an error and take a look at what the issue is. Here we can see that Doxis4 can easily ingest and make available the metadata from many sources. The web client is called via a URL in an iframe. The KML layer, which is used for the lines and substations, passes parameters to the URL to perform a targeted search. The source of the problem would appear to be a nearby substation, as we can see here in the description field. Therefore, we will switch our attention to this substation. The description notified us that the problem was related to the Willington substation, which is supplying too much power to the grid. Therefore, we will now select the Willington substation. This time, we don't get a result list, but instead we get the actual file for the substation. In this file, we will find all the relevant information related to this substation, including all documentation. The remote service engineer thus has access to all the documentation about this substation that they need to work on this issue. Here, the parameters are also passed through in order to ensure the correct file is opened. In this case, it is that of the substation ID. We'll open this document, and the remote service engineer will be able to use this manual to search for a solution to the problem. To save them from having to page through the whole document, they can open it in a read format and then simply search for the word overload. Straight away, we can see there is some information on remedying the error on page 32. We would therefore like to highlight this whole section. So let's jump to page 32, and using the annotation capabilities, we will highlight the section. Now that we have identified the issue, we need to engage a local engineer to fix the problem. We'll therefore send a service request. The on-site engineer has now received his service request assignment. We will open this on his tablet device, i.e. in Doxis4 Mobile Cube. Here, he can see his new assignment and all the information related to the substation in the same way the remote engineer could. The on-site engineer can also view the instruction manual, and if they select page 32, they can also see the annotation that their remote colleague has already provided for them. The engineer has since found the source of the problem and wants to submit a photo of the offending component to ensure the whole issue is documented. We therefore use the Add Attachment capabilities of Mobile Cube to submit a picture of the component. The engineer will add some supporting comments and confirm the problem has been remedied. They save this, and the image is now linked to the case file. The colleague can now mark the assignment as complete. The remote support engineer is automatically informed that the issue has now been resolved. If the remote support engineer now refreshes their GIS map, they will see the alerting place marker has now been removed.